Welcome to ArmanisMath. Today we're going to focus on the number sets and also the notations, set notations. And let's start with the first thing, which is a warm-up. We are here asking for the following simple problems here. 3 problems. So as I usually do, I give you about a minute. If you have some answers, okay, so let's start with this one here. It says write in a decimal form. And can somebody use the chat on either YouTube or the live chat or the here we go, got 0.5. By the way, remember that the chats and the whiteboards and all these are used for me to gauge your knowledge. So if I see a lot of correct answers, guess what? I'm moving on. And so that's why I'm saying use the whiteboard, the chat, the live stream feedback to show me incorrect answers, not just correct answers. Because once you show me incorrect answers, I'm able to help you learn what's going on. Okay. How about number 2? You use both the live stream chat and also the other one as well. Okay, the store opens for 8 hours. That's right. You could say that the store opens for 8 hours. It's fine. How about number 3? How would we graph this thing or plot this thing on the number line? Obviously, you can, and that's what I'm saying. In the future, I need to see your own whiteboard. So you turn on the camera and then you just put the whiteboard in front of the camera so I can see. But for now, do you think I'm gonna go right or left from the 0 here? Should I move right or left? Okay, somebody said move to the right. 1, 2, 3. And do you want me to bubble in the circle? Bubble or not bubble? Bubble. Yes, indeed. I bubble because equals. So if there's equal to, I got a bubble. That means I'm including that value. If you're not including the value, you don't bubble. But if you are including the value, you've got to make a circle. It can't be open, it has to be closed. And that's why you say it's included. So what if I said, for example, x is less than or equal to 1? Do you think I'm going to bubble or not bubble? Okay, be careful. One more time. When do I bubble? I bubble when I have an equal sign, but there is an equal sign here. See that, dude? There's an equal sign. So whenever you have this is less than or equal to. If you read this carefully, it says x is less than or equal to, which means I do have to include, which means 1 is part of the solution. So if that is true, if I said x less than or equal to 1, I've got a number line 0, 1, and I have to completely cover the 1 because of this. See that? See this thing? That means I have to bubble that. And obviously if it's less than 1, you go to the left like this. So that's x is less than 1. I'm glad that you guys gave me incorrect answers, and that's why I'm going over this with you here. So let's do one more. What if I said, how would you graph x is greater than or equal to, let's say 2. Should I move left or right? Right, okay. So I am here, this is 0. And let's say every tick is 1 and 2. Okay, so I have do I bubble the 2 or not? Do I cover the circle for the 2 or not? Do I cover the circle for the 2? Do I bubble in the 2? Yes, I do. And I'm not sure why I can't see any feedback on the YouTube live chat. Not sure why. Is it because of the delay? I'm not sure. But make sure that you're able to use both of them. So I am actually gonna cover this one, bubble that, and I'm gonna move this way. Move this way. That means like I'm going to 3, 4, 5, 100, 1,000, 1 million, 1 trillion. 2 trillions. I think the last stimulus package for the pandemic was about 3 million. The first one, 3 trillion, I should say, and the second one, I believe now they're negotiating 1.5 trillion dollars. That's way too big over here. So this keeps going and going and going and going until you get something called infinity, which you can't get to, but you're headed towards that number. You can't hug infinity. It's too big of a number. Okay. I mean, I tried to give it a hug, but I couldn't. Objective. A student will be able to use basic concept in algebra to solve interval and inequality problems. So go ahead and write the objective down. Student will be able to use basic concept in algebra to solve interval and inequality problems. When you use yes, Johnny, that you're right. You actually bubble when there's equal, but also don't forget, Johnny, that there is an equal to or less than or equal to, greater than or equal to. That means you do include the bubble as well. Okay, let's move on. I need one word from the objective, please, in the chat. One word from the objective. Either chats is fine, the YouTube or the live stream or the or us here. Come on, you guys, go for the big boards. Why do you pick one and in and come? Oh, come on. Okay, here we go. Let's move on. A real-life example of inequality would probably be something simple like adjusting the AC thermostat. So as you were going through the heat wave and you wanted to, I'm going to put a thermostat here, or try to, I guess, because I'm not too good at drawing stuff. But let's say I have a thermostat that looks like this. Right, keypad here, and you wanted this thermostat to stay at 78. You want the temperature to stay at 78. Okay, it's summertime. This is the hottest that you could handle. So what you're saying is, whenever it goes to 78, you want it to keep it less than that. So you want it to be less than that, this amount. I mean, so X for you is going to be less than 78. Anytime the temperature goes beyond 78, the AC would turn on and kicks it back. Try to do it hard, as probably it's overworking these couple weeks here to maintain this 78 that you wanted, or whatever temperature set that you have. Okay, so this is an inequality, believe it or not. And if you have set, or a few of your folks have set this to be like within a range, like programmable. So for example, you could go less than 78, but you can't be freezing. So maybe you want it to stay at 70. So it will not go below 70 and not above 78. And if you're going to be facetious, you actually could put like this. When it's exactly 78, ding, the AC would go off and will start cooling things down. Exactly 78. Okay? So you still could use that in real life application. If you think of a different example, you might want to Google and then share it with us if you'd like. There's a lot here that we need to mention, but not really spend time talking, because we're going to talk about each one of them individually. Okay, first thing is set. It's a collection of elements. Element is what defines in the set, so every set has elements. For example, let's say a set here would be something like a set of your clothes, okay, in your closet. An element would be maybe one pants or one shirt. Of that amount of your clothing, there's one shirt. So element is a set. A shirt is an element. It's one thing of the set, which is your clothes. Subset would prefer to, for example, if you have a bunch of shelves, and then let's say that you have a shelf here for your shirts, pants, let's say your socks. So a subset. Remember, oh, this is your clothes, right? This is your closet. So shirts. What did we say here? Pants. And then socks. So once a subset of this clothing would be maybe just a shirts subset. That's a portion of a subset of the big one, which is your clothes. Empty set would be something like this. For example, that you or your I hope that is you helping with the laundry, but you have you're out of socks. I mean, you really have to have wash. All of them are in the laundry. There's no socks here. That's what defines an empty set. Okay, so there's nothing in here. You're just waiting for that laundry. Roster notation would it's cumbersome. This thing, roster notation. This one has a detail, like you really want to list every single shirt, every single pant, every single sock, with a color, with a size. So like I have, for example, a navy blue shirt, comma. I have a yellow shirt, comma. I have da-da-da-da-da. And then you list all of them, which is kind of fine. Like, for example, in your class, I have a roster that lists every single student. But that's not going to work for a big list, right? Big sets of numbers. It's not going to work. I can't say, for example, I want to have a roster for all students in my associated schools. That's, come on. I mean, do you want me to list every single one of them? I think we're about 30,000. I'm not going to do that. So that's why this thing is good in little things, but not in large things. Finite set means things that are the definite number of things, okay? You know that you have, for example, 5, 6, 10 items. So you have a finite number, a limited known number. Infinite number, obviously, it's the opposite, which is the numbers are getting really big. For example, what have I said? What have I told you right now? Go ahead and give me a list of odd numbers. Okay, give an example in your chat. Odd numbers. Okay, numbers more than just one. So what you're probably gonna start with 1, 3, comma, and then what? Well, that you're gonna keep going and going. Okay. So that's an infinite set. This guy here is called interval notation, which we use to determine the end point of a set. For example, like that 9 to 5 hours calls store hours. So for example, I want to store that I start from 9, so I use bracket because I open the store exactly at 9, and then comma, and I use a 5, and I close like the last minute before 5. So if I'm not going to include the 5, I'm going to put parentheses. If you want to include things, you put bracket. So let me use a different color. If you want to include things, you put bracket. If you do not want to include things, like but up to that amount, up to that point, up to that end point, you use parentheses. Okay. One of the things that you need to use parentheses for, you have to, is infinity. Because infinity, you can't really hug that number. It's too big of a number to hug. So that's why if you have an infinity involved, you gotta have to have the parentheses. You can't just say bracket for infinity. It's not gonna work. Because bracket means including, and you cannot include infinity. I bet you a lot of us will benefit from watching this video very carefully after we finish, because there's a lot of information here. I told you that starting Monday we're gonna have to dig a little bit deep, so get up for that. Set builder notation. This is another notation that they use. So for example, instead of saying every single student, and I would name every single of them like the roster, every single one of them, Johnny, Ayala, and then Kiera, and then Olivia, and no, I'm not going to do that. So there's another way to do it, which is called set builder notation. Usually we do not say the word builder, just set notation. Okay. So what does this mean? It starts like this. Obviously, we're going to talk about this a little bit further, but just heads up. So it looks like this, a curly bracket, and then you put, for example, let's say X, such that, this line means such that. I'm going to use different color as well. So such that. So you start with your, whatever the number is, like X could be a student. Such that X, such that, this is how you read it. A set of, curly bracket, a set of X, such as X is in Armani's Algebra 2. So that is going to include everybody who's in Armani's Algebra 2 without me actually going through a roster list of things. I'm not going to list every single one of them in a roster, but I'm going to use this set builder notation, or you could also just say the set notation. So a set would be curly bracket, a set of X such that, see that line, such that X is an Armani's Algebra 2. All right, more on this to come. Just quick preview here. Okay, here's a raster notation. A raster notation is not suitable to represent infinite sets. Well, obviously, we just talked about this, right? You can't be sitting here counting 1 through trillion in one set, unless if you're a mega computer and you have the time that you need, but obviously not me. Or not you. Raster notation is not suitable for infinite sets. It's probably useful for finite sets. Finite is very limited, you know. For example, if you want real numbers between 5 and 6. So think with me a little bit here. Johnny, stay with me. Andy, think with me a little bit here. If you are between 5 and 6, so like this example here, 5 and 6. And let me use my tool here. I'm between 5 and 6. Think. I need you to think. This is 0. And this is 5, and this is 6. Let me give myself more room here. So this is 6 here. What numbers are between 5 and 6? Can somebody know? I'm sorry, 5 and 7 in this case. Let's put 7. 6. Good. What else is between 5 and 7? Not just the 6. There's something else. Exactly. 5.2, 6.1, 6.4. Come on, be courageous. Expand your knowledge a little bit more. 6.2, 6.1. Is there more? That's tough. So what do you mean by that stuff? What else can there be? Exactly. Here, you just did it. You went to the second decimal. Second significant. So 2.5, 2.523, 2.55555. How about 5.77777777? How about 9.9? How about 6.9999999? Obviously. Well, yes. So what we're trying to say here, to put this in raster, it's not going to work for you. It doesn't. You have to use something else. Okay? You have to use another method to represent that. And in this case, here is a couple other ways to represent that. You could put this in the set of real numbers between this and that on the number line. That's one option. So I could just represent that in the number line. So I'm going to put a line. I should start not having this dashed. It says, here's the first one. And I could say this is between, let me put 0 down here. Let's say 3 and 5. And obviously, pay attention, this line is actually has a ray, and the ray goes all the way to infinity, okay? Now think a little bit here. So you wanted the numbers, all real numbers, and we did not define real yet, but real numbers would also include the decimals and it would include the fractions. It's a big set of numbers. It would include the whole numbers, natural numbers, which we're gonna take a look in a second. But just make things simple now. If you wanted the numbers between 3 and 5, here's 3, and you obviously have to have a circle, and 5, you have to have a circle. Now, do I include the 5 and 3? It doesn't say that. It doesn't say including 5 and 3. Did you see that? It doesn't say including 5 and 3. So you got to leave it open, and in this case, you just have to connect these two circles. So you are in between these two numbers, just like with the example that you gave me, 3.59. 4.999999999, and all these other ones that go into here. So that's the way to represent it. I'm not going to do raster because raster would not work for this. It's infinite. The other one to use is called inequality. You could represent this dude here in inequality. So the number that you're looking for, which is x, has to be, if you look here closely, you are more than 3, right? So you're greater than 3. Remember, the alligator opens up to the big guy. Alligator, remember that? Greater than, less than. So, just a quick example here. Cha, 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 cha. Cha, 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 cha. Alligator, okay? The big guy goes here, big guy. And here the small number goes here, okay? Whatever the number that you have. So, when you read this, you read from left to right. So, you're saying x is less than the alligator big guy here. So 3 is less than, so in this case 3 is less than x, or you also could say, the traditional way in math you say start from the variable. So you start from the variable, which is x in your case. X is greater than 3, and at the same time you are less than 5. You're not touching 5, you're less than 5. You are above 3, you're not 3, you're just a little bit above 3. Just a tad. Okay? That's another way. So both of these methods are used to represent numbers that are not suitable for raster notation. Infinite. Too big numbers. This is how you contain them in math. You could graph it like this on the number right, or you also could use inequality to represent that amount. Okay. Here's two numbers, for example, between 2 and 4. Between 2 and 4, there's a lot of numbers, and I can't put that in raster notation. Okay, now let's talk about interval notation for a second. So interval notation defines a set of all numbers between two endpoints. One more time. Interval notation defines a set of all numbers, all of them, between two endpoints. So for example, like between 1 and 7. So what is the interval notation? It's another way to represent set of numbers. Another way to represent set of numbers instead of just the number line and also the inequality. A third way is to use the interval notation. And interval notation is very simple. You use brackets and parentheses. If you want to include the endpoint, you use bracket, just like this one here. If you do not want to include the endpoint, you use parentheses. So for example, I have this inequality here, which is, I have an equality between 1 and 7, 1 and 7. And if you could look closely here, I have this dude open circle because I'm not including the 1. Obviously, there's no equal to here. How about the 7? Same thing with the 7. You are less than 7. You're not touching 7. If there's an equal sign here, that would be a different story. But this, you're not touching 7. Okay, so how would you put that in interval notation? Well, here it is. In interval notation, you put parentheses because you're not including the 1. See that? You're not including the 1. Comma. And then the other number, the other endpoint. And then, are you including it or not? Well, in this case, there's no equal sign. That means I do not include it. So that's parentheses. So basically, I have parentheses, 1, comma, 7, parentheses, which is an interval. I asked this question earlier today, so I'm going to ask it again for you. What do you think I could confuse this with? What could confuse me with this? What other math thing that we use this notation that could kind of mix my knowledge in math? Go ahead and help me in the chat. Yeah, okay. If you could explain a little bit more. Guys, I need you to respond in the chat, please. What could this be meaning? So this 1,7 could mean something else which you use. Other than the word, unless if you're referring to something else for that word vertex. I mean, it could mean that, obviously. I'm looking probably for a larger concept, not just a vertex. Where else can you see 1,7 in your math life? I show you parentheses 1,7. What do you think? Yeah, a graph. That's right, a graph. A graph of what? I know I'm trying to focus on one thing. A graph of slope, or here we go. That's it. A graph of a point. And a graph of a point could be x and y axis, which we call Cartesian coordinates, or Cartesian coordinates, and then you could just 1, which is here, and then 7, 1, and then 1, 2, 3, 4, 5, 6, 7. So that could be the point 1,7. However, if you paid close attention in the interval here, you are dealing with one variable. See that? One variable. X is between this and that. In the Cartesian coordinates, you have two things happening. This is x and this is y. So there actually should not be any confusion. If you are dealing with intervals, you are dealing with what? With one variable here. See that? On the number line, one variable. But down here, the x and y, you are dealing with two variables, x and y. So you should not be confused. They do look alike, obviously, but we should not confuse them. Before I go to the last item here is the idea of infinity. Obviously, there is no way to contain infinity here, right? We said it's too big to hug. So if I were to write infinity in interval notation, it has to be negative infinity, comma, infinity, and both of them can't touch. I cannot touch them. So that's why you have to use parentheses for both of them. From negative infinity all the way to positive infinity, not including either of the endpoints because it's too big to contain. Lastly, I'm going to just go over here, quick review. If you wanted a number less than 3, this is what you do. You take the circle, go to the left. X is less than 3. How do you put that in interval notation? Well, you go start from negative infinity all the way to 3, not including 3 because there is not equal to. Second example here is the number is greater than negative 2 or equal to. So you go all the way to equal to greater than infinity. You bubble in because you are including it, right? And then how do you write that in interval notation? Well, you said you want to include negative 2. So you have to have a bracket all the way to infinity, which you cannot hug. Third, we talked about between two numbers. X is between 2 and 4, and x is parentheses 2 comma 4 because you're not including either of them. Last but not least is the number is from 1 to 3, including the 1 and 3. So I do include the 1, I do include the 3 in the inequality by having equal to, and I do that when the interval, when I have a bracket to represent that. 1 minute of hope for the money. I was so pleased, we all, I believe, so we're so pleased and happy to see just few sprinkled drops of rain yesterday. Thank God after this heat wave, and we're still praying for more rain, I guess. But it was really cool to see that, and that just gave us a little bit of hope that though through the pandemic and also through the heat wave, we still have some mercy, and we still have some just a little bit breezier. So enjoy that, and for that we are thankful, and we're hopeful, obviously, that things will always improve. Okay.